Good. Um, uh, I'll give it a moment because I can never tell. I always just export from Twitch to YouTube, and YouTube videos are always a few seconds where it didn't hear it didn't catch me actually the things I was saying. It said I was streaming, but I wasn't. So yeah, hopefully we're good to go and nobody's missing anything. I'm just gonna wait. One more thing I should have done before I actually started is move this out of the way. Done with that now. Alright, so I have here a zip of my Intro to C programming lessons. There's basically one of them right now, and a second one that I'm still working on. And I have noticed, after a year of working on it, that I have a bit of trouble making lots of progress because anytime I sit down to work on it, I type in a little bit of stuff, reread what I've got, and I don't love it anymore. And then I go, okay, hold on, back up. And so progress is very slow because of how often I end up going, you know what, this isn't working, and redoing it. And I found that even after lots of backtracking and trying to make it good, the thing I ended up with, I look at it with fresh eyes, like, a week later or 2 weeks later after I get some feedback from other people, and I think it's garbage again. So there's not, I think, any point in me trying to work on it meticulously, but I don't really have, I'm not used to just writing things down and flying through it quickly in a way that, and then going back and editing it. That's, it's not a skill that I have. My instinct to go and edit immediately is very strong, so I'm going to try to develop the skill of approaching this a slightly different way. And I've also found that when I'm having trouble staying on a particular task or trying to change a habit, having people watching me and calling me out when I'm not actually changing that habit seems to help. So that's why I thought this stream might be useful. So that's why we're doing it. Now, I guess there's not much else to say about it, except let's get into what this is all about. So I copied this all over for my Mac, so it's got all the crazy greenness that I don't even know how to do that on. I don't know how Windows even. I don't know how that happens. Basically, the idea here, you can see I have this thing called Lesson 6. That's just some stuff that I split off my first version of Lesson 2 that I decided wasn't appropriate. Then I made a second version of Lesson 2 that was called Draft 1 for complicated reasons. And it was basically the second Draft 1 where I was framing Lesson 2 as a completely different topic. Didn't like that at all, and now we're working on Lesson 2. But I think what I'd like to do first is just do a quick sort of high-level overview of what's covered in Lesson 1 and what the goal of these lessons is, so that if people start wanting to give me feedback or following along with the progress of this project, they have some kind of context for what's going on. And this README and roadmap, by the way, are so far out of date that maybe one of the things I should do today is just make sure that these are updated. But right now the situation is that I have basically this goal of creating the lessons for learning C as somewhere in between. I want lessons that are useful for people that are somewhere in the range between learning C as a first programming language and learning C having already learned programming, which obviously those are two different things you could approach. You could make a more specialized lesson, but I don't think there's really, I'm more thinking about the information that I want to provide, and I feel like the information that I want to provide would be useful starting from either of those positions, because I'm sort of taking the assumption even if you know programming, not only am I introducing you to how C works, but also kind of a way to look at programming that you might not be familiar with, so it could still be valuable for you to go through this, even though it somewhat targets people who haven't done much programming or any programming at all. Um, so, um, yeah, that's basically the broad level goal. Um, and the approach I'm taking, basically, so the next big item on the sort of philosophy of these lessons is that I looked at I looked at a bunch of the lessons that are out there. I'm not going to say most because I probably didn't even get through like 1% of them, but I looked at a bunch of them, and there are a bunch of them. Uh, and the ones I saw that all were like near the top of Google searches and the top of people's recommendations for things, they all had the basic property that they, for the most part, especially the ones I didn't like, were heavily geared towards sort of just laying out to you, here are the fundamental building blocks, like here is main and printf, and here is, um, doing addition, and here is a variable, and so on. And that's pretty much what's out there all over the place. And I don't want to just make another one of those. I wanted to make sure we were doing a lesson that was at least unique, if not anything else. So I thought it looked a lot more like the other approach, which was instead of starting with fundamental building blocks, starting with something slightly bigger and decomposing it was out there, but it was not as common. And I think that's an approach that fits better with what I wanted to talk about in the lessons more anyway. So that's the way it works. I basically have lessons where you get some code that was written and for you, basically, for the purpose of the lessons, and then the lesson takes you through understanding what some portions of that code does and how to experiment and modify and build out those portions of the code yourself. So that's the basic philosophy. Lesson 1, which is mostly done, basically teaches you what your compiler, teaches you how to get a compiler, or at the very least sets you up to use your compiler. It's not really comprehensive. Here are all the features of your compiler. It doesn't contain the actual installation instructions for your compiler. That's going to be on the network, hopefully, but on a different page. It's more like, it tells you to get your compiler and the other things you're going to need to start programming, and it walks you through the process of compiling something and then kind of what your compiler just did for you, right? And that's basically the entirety of lesson 1, is getting familiar with the idea that you have a compiler to make your program for you out of some code. So lesson 2 is supposed to be the first lesson where you start doing lots of programming, and the approach that lesson 2 takes is that it has this painting.c program, which we're going to take a look at. And painting.c basically has a main and a procedure that prints out a bitmap file, or basically it does the necessary things to create a well-formed .bmp file, and all you have to do is pass in the pixels that form an image, or the data that represents the pixels that form an image, right? And the idea of lesson 2 is to learn a little bit about the math operators that are available to you and playing around with doing addition and arithmetic basically in the variables to get various crazy patterns. And so, the patterns we have right now are things like these here, right? You can make these kinds of things, plus much more if you experiment just a little further. This is the stuff that the lesson directly shows you how to do. It's like plug in this equation and how pops one of these crazy images, right? And for instance, this one, oh gosh, no, not Photoshop. Why would I want you to open Photoshop? That takes forever. Go away. Does preview go more quickly? Not Photoshop. Why would you also override preview? Come on. You shouldn't be able to be open and preview. This is ridiculous. Go away. Go away. Sorry about this. Let's do it the direct way. Let's open this with Google Chrome. There we go. Okay, so this is this is the division one. There it is. It says it right there, which basically means we're taking x divided by y. It's actually, what does that say right there? Is that x times 256 divided by y? Yeah, so that gives us this pattern here, which, you know, it's kind of neat. And that's the whole idea, is to just make these things and then kind of explore why was that picture the result, and learn from these pictures kind of the behavior of the arithmetic operators, and then, you know, have that as a basis from which you know how to experiment and make other wild gradients that aren't just handed to you. So that's kind of the idea of the lessons. Now, with all that, or with lesson 2, with all that stated, let's take a look at what I've got so far. That's kind of distracting. Now, what I would like to do is get to maybe like that. It's going to wrap the lines the wrong way because this program sucks. Whoever made it should, you know, feel bad about how bad it sucks. Okay. Yeah, that doesn't work. Okay, well, let's just do this. really long lines. I was kind of trying to avoid that. I don't know. I don't know what the best way is here. I guess this is the best I can do. So, there we go. That'll be what we work with. Alright, so, what we have in lesson 2 right now, I'm not really sure how to stream writing this, but let me just take a moment to read what I've got so far. I'll read it out loud so that we're all caught up together and we're not just sitting here looking at me staring at a screen. And then I'll figure out what I want to do from here. So, the name of this lesson is Painting with C. We're going to make digital paintings with C programs, although this technique is far from how so the first lesson references Bob Ross. It's like a metaphor to get the whole thing, to kick the whole thing off, and to be a little bit of fun. Just a very small. I don't want too much fun. You know, just a small sprinkling of fun is more than enough, really. We hope he would approve of our own creative method. In this lesson, we assume you have set up your compiler and can use it, and we assume you know about what. We assume you know. See, this is where I'm going to start editing it again. We assume you know about what machine code, assembly, and C code are. Jeez. And we assume you know. And we assume you know what machine code, assembly, and C code are. We assume you. That you are familiar with. Okay, stop editing. Okay, all of this was in lesson 1. So if you've been through that lesson, then you are ready for this one. Yeah, I don't like that sentence either, but I'm not editing it right now. See, this is why I never make progress. Is every day I end up rewriting the whole thing, and then I make like 2 or 3 new sentences before I'm like, aha, I have to stop. I have to stop for the day. I'm too distracted. Alright. The base painting, program. You know, I'm gonna make a quick. We're gonna make take a couple of these because I personally want to keep my Bob Ross metaphor going the whole way through all the lessons, and put in these jokes. So whenever you guys provide those, I'm just gonna grab them and make a little list over here in my scratch buffer for later. All right. The base painting program, painting.z, is approximately 100 lines long, and for this lesson we will zoom in on a single part of the program that we can alter to change the patterns of colors and gradients that are. This is such a long sentence. Oh my god. Okay. Anyway, not editing right now. Along the way, we will learn how the binary patterns of bytes can be used to manipulate numbers and colors, and the arithmetic that our program can do on numbers. Do not be worried if most of the program does not make sense right now. We will be making sense of this program piece by piece over the next lessons in this series. Get it working first. That's the first heading here. So the idea of this heading is just to walk them through actually compiling and running the code. So let me pull the code up real quick to show you what exactly we have going on here. Yeah, Flying Solomon says that I have to stop being critical of the content or stop being critical of the formulation and focus on the content. I agree. That's kind of what I'm hoping the stream will help me learn to do, because that's what you're seeing me do right now is the same thing that I do every time I sit down to work on this, which is why it goes so slow. It's like an n-squared thing where the amount of work the nth day takes is equal to the length of the lesson already plus 1, and then and the next day I don't make I have to do that much work plus 1 again. Alright, so the idea here is that the idea here is that this right here is the first thing they'll see when they open the file, right? So like, I've got here, it's at 14 lines, there's a good chance that they'll see the entirety of this main when they open it. And that's what they have to see. So section 1, setup, these sections are from lesson 6 stuff, don't worry about that. Later on in the lessons, the fact that there are sections will mean more because it'll say how we'll use the sections to reference what part of the code I'm talking about at any particular time. So Gwynereth says, "Isn't it bad practice to cast the return value of malloc?" So here's the thing: in C, you never have to cast because void implicitly casts to other types of pointers. So in C, you can just do this. This would just work. In C++, you can't. Now, I'm writing in C, so the question is, why am I casting? And the answer is because I'd like to give beginners as few things to be confused about as possible. And so if they have any C++ background, that could confuse them. If they learn this and then go and try to use C++, that could confuse them. So I'm using the subset of C and C++ that works on both compilers. Okay, so So the idea is that when they open this up for the very first time, this is a code file we'll be looking at a while through the course of the lessons. That the thing that hopefully their eye is drawn to, and fucking like software is organized in the way where I can't be arbitrary about the order. These things have to come first. Like I can't have it ordered in the way that is correct for the lessons, which is to have this first, because what's correct for the code has to go like what's correct for the code is outweighs what's correct for the lesson, and unfortunately, what's correct for the code is that all has to go first. But then you can see this code here, which is the part they're actually going to, the users of this lesson will actually be editing for all of lesson 2. So the first thing I want to do is tell them to compile it, and then basically this portion here that computes W will mess with it and do small things, and then I'm going to try to, in this iteration of the lesson, the idea is start by introducing them to the couple of operations and explore why those operations produce the images they produce. And then once we've looked at all the images I showed you, we'll go on to explore combining things in more complicated ways to try to like challenge problems like, can you make this pattern kind of thing. And then finally, there's a separate thing that might go into it's part of the layering of the lessons, where we will look at the assembly for the operation, the operators, which we would do by looking at a different file here that just boils down to that. And then when you compile it, you would compile it to a .s file so you can see the assembly, which is something I'm going to do in every lesson. So whatever thing we're playing with, we also take a minute to look at what the compiler does and what the assembly looks like when we just make a .s file. Okay. Okay, so before we dive into the main topic of this lesson, let's first make sure that the program is compiling and running correctly. Okay, first we need a folder for our experiments and a code file in it called painting.c. Before I go any further, I want to make an outline of this whole lesson, and then I'll write this out. So after we get it working first, we're going to do I want a section on bits, numbers, and colors, and then I'm going to do arithmetic, picture. Okay, and then explain. So in this one, I'm going to explain the correlation between bit patterns, integers, and shades of gray. Right now, we're just dealing with a situation where R, G, and B are all the same. Pretty soon, we'll maybe even by the end of lesson 2, but if not, pretty soon in the series of lessons, we'll make it more fun and get off of just this weight and do RGB separately so that we get colors too. Start looking at different operators and investigate why certain operators produce certain images. Yeah, I think this is a better order than the one I did in the first draft, because this will give me a good reason, a well-motivated reason to talk about wrapping at the beginning, which will then make it possible to explore this question without as much deferring to things that are coming later. And then finally, we're going to do the arithmetic in the assembly. Look at how changing an operator changes which instruction or instructions are generated. Alright. Sorry I got distracted by the chat and I was just catching up with what everyone's saying. Let's keep writing things. So, first we need a folder for our experiments and a code file in it called painting.c. I don't like any of that. Okay. Get the painting.c program provided with here. I can link things in my in my articles, right, Abner? Bye bye, Ginger Bill. See ya. Thanks for stopping by. And put it. First download and open it in your text editor to check it out. Again, you don't have to understand everything going on. Everything that is in the code. But take a quick glance at it to get something like that. Who knows? Formulation doesn't matter, right? Keep moving here. Make sure you know what folder you have your painting.c file. The folder where you code file. So next you will need to start up your command line and navigate to it like we did in lesson 1. If you want, it might be a good idea to put this code in the same folder as the same lessons folder we made in lesson 1. I want to check that I actually told them to make a lessons folder, because in one iteration I did, but that might not be the case anymore. Flying Solomon, am I still doing it? I can't tell. I felt like I stopped doing it, but maybe you were talking about something earlier that I did. I need a little bit of space here so I can read it. This is totally legibility for my own sake. Alright. Yeah, I always end up describing how to get these details right. Even though they're not the primary thing that almost anyone could write this part, but I want to make sure that it gets done by somebody, and I'm here writing it right now, right? All right, so, but I'll try to move past it. So it's because the same lessons folder we made in lesson 1. Yep, that's as much detail as it needs to go into. finally launch your compiler like we did in lesson 1. Or launch your compiler to build this program like we learned to do in lesson 1. I'm going to pull up lesson 1 real quick because I can't quite remember the format for how to do this. GCC, give me a GCC instantiation example. There we go, that's what I'm looking for. Forgetting the markdown format there. Okay, let me pull up Scratch again. Like we did in lesson 1. Alright, so this is painting.c -o painter. Now, check to make sure you have the new program. And stop to troubleshoot if you don't. Finally, run the painter to make sure it creates images is working. I'm leaving these little exclamation points everywhere as my to-dos. Unlike code, there's no way to like leave a comment, and so I don't want to spam to-do everywhere in the text. So that's my to-do mark instead. And the reason that has to do on it is because you can't fucking run the programs the same way between operating systems. Right? If you try to run Painter on Linux, you have to do the // but on Windows that wouldn't work. Jesse Meyer asks, have you considered authoring these tutorials in the literate programming style? I've looked into literate programming a little bit. I don't totally understand it because I've never looked at any literate. I've never looked at anything written that way because I just looked up a definition and I didn't really get the definition, but I didn't put a lot of time into it. Maybe I should look into that more. As I understand it, though, isn't that like about well, I know like part of the reason I didn't continue is because I couldn't even tell which definition was correct. One of them sounded like writing code in such a way that it reads very much like English, and the other was like writing code and like heavily commenting on every single part of it, like you're describing something along with the code, some sort of. I don't really totally understand what it means. Which is why I didn't keep pursuing it after I started trying to figure out what it meant. If everything worked, you should now have a bitmap image in your directory that looks like this. We'll link that image there. Okay. Okay. Alright. Shades gray. Yeah, Philadelphia still has the same confusion that I am having, which is I still don't know what an example of it is. Is it about the code you're writing, or is it about a book about code? Like, I would need an example of what you're talking about so that I knew for sure that I was understanding, because I feel like people haven't defined it for me in a way where I could go look it up and know I was looking at it. Alright, okay, so bits, numbers, and colors. So what we want to talk about in this section is we want to explain basically the relationship between bit patterns inside of a single byte, integers, and colors, the shades of gray. So I think the way I want to try to go about this is to say that really all there are bytes, but we want to represent various different things. Alright, to understand how this program is painting a picture, we have to learn about how computers we have to learn about what even allows computers to reason about colors, to create and manipulate, to manipulate colors. At the very bottom level, all a computer has for storing information is bits. Where do the colors but somehow that so it might seem that it shouldn't be possible for a computer to even store a color in its memory. So how are colors even stored? That's good enough. There we go. Alright, let's take a look at this real quick as it pertains to let's do that. Okay, Thanks, Flying Solomon. Um, Past 10 years have witnessed a substantial improvement in programming methodology. Its advance carried out under the banner of structured programming has led to programs that are more reliable and easier to comprehend, yet the results are not entirely satisfactory. My purpose is in the present paper is to propose another motto that may be appropriate for the next decade as we attempt to make further progress in the state of the art. I believe that the time is ripe for significantly better documentation of programs, and that we can best achieve this by considering programs to be works of literature. Hence my title, Literate Programming. Let us change our traditional attitude to the construction of programs. Instead of imagining that our main task is to instruct a computer what to do, let us concentrate rather on explaining to human beings what we want a computer to do. The practitioner of literate programming can be regarded as an essayist whose main concern is with exposition and excellence of style. Such an author with thesaurus in hand chooses the names of variables carefully and explains what each variable means. He or she strives for a program that is comprehensible because its concepts have been introduced in an order that is best for human understanding, using a mixture of formal and informal methods that reinforce each other. I dare to suggest that such advances in documentation are possible because of the experiences I've had during the past several years while working intensely on software development by making use of ideas of structure because I couldn't bear to be found guilty of writing chance to get a hit bike. I just want an example. I'm sick of definitions. None of them clarify for me what anyone's talking about. Is that code? That looks like pseudocode, though. Alright, I'll read this more closely at some point, but I still don't even have really a feeling for what it means. I mean, I guess I get the idea, which is to write good code that makes sense. I don't know. Maybe I'm being too obtuse. Okay, let's keep working on this thing over here. Okay, at the very bottom level, all a computer has for storing information is bits. So how are colors even stored? How is anything stored that isn't a 0 or 1? Recall that a bit is just a piece of memory that can be either in the on state or off state. Anton Swift asks, why did you decide to rewrite it from scratch? I just, after reading some feedback, it kind of, like from you and from, I forget who the other one was, it B-Business, a few people gave feedback, and it got me thinking about, like, it gave me a chance to look at it with fresh eyes, because I'd been kind of mired in it, like, bogged down in it for a while. And I was like, okay, I'm ready to look at this with fresh eyes after I had that feedback. Like, okay, I want to see and evaluate if I like it at all. I didn't like it. I mean, I still like the main goal of it, but it was in the completely wrong order. And a couple of the suggestions, I think, will totally fix that. Part of the problem is because it takes me so long to write these things, because I don't just power through and get a lot done every time I sit down. Since it takes so long, my idea of the best way to answer certain questions changes over time, and so I set out to structure it one way and end up wanting it structured a different way, and it was all messed up. I'm going to back up what Flying Solomon is saying. I actually did that back when I was in C++. I've deleted these videos from my channel now. But one of the first things I did when I was learning programming and I was learning in C++ was I studied and learned the different STL containers because I was using the template library. And they have all those containers like list, vector, map, set, deck, and I think that's all the ones I can remember. And I basically went through and like made a video series on the characteristics of each one. And that being able to get that under my belt was one of the first sort of things that got me ready. Like, you kind of have to have that down to really feel comfortable building big things. And I would say it isn't enough to just have it in a table somewhere. It's more like you want someone to explain it out. You want to be able to digest it, like internalize it. And a table just makes it look like a thing to memorize, but it's really not a thing to memorize. The thing to memorize is the definitions of the algorithms. Once you know, for instance, that sort of just a flat array has the property that it's stacked in a certain way where there's no space between two elements, it becomes very clear why inserting takes longer there than in a doubly linked list. You want to be able to derive the values for the table from the implementations. That's how you know you understand it. But maybe for a wiki it would be fine. It's not a particularly useful wiki because anyone who knows it doesn't really need to look it up, and people who don't know it need the understanding, not the complexity classes. Okay, okay, so we're going to go on with the answer. The answer to the solution. The way a computer stores these more complex is by grouping bits together. The most basic grouping is built in at the hardware level, putting bits into groups of 8. These groups of 8 are called bytes. most memory, and most things are, and things like memory sizes, or things like sizes of files. I'm going to leave it there. Hi, code editor. Welcome to the stream. Don't look at the chat. I'm sorry. I can't. Let me turn the screen monitor off for a little while. Okay. We're going to see if we can't do 10 straight minutes of me looking at this screen. These groups of 8 are called bytes. What I want to say now is sort of how does grouping help? Don't we just have 8 zeros and ones now? Well, if we consider the byte to be the whole byte as a single object instead of 8 little bits, then one thing we can see is that the byte has many more states, more possible states. A single bit. This is where I don't remember how to make tables in Markdown. And if I go look it up, I'll probably end up seeing the chat. So instead I'm just going to, build a table like this, and I'll leave it up to someone else to do the formatting, and by someone else I just mean me later to do the formatting correctly. Two possible states. Alright, I'm a little worried that that 256 comes out of nowhere, but I'm trying to make a faster paced thing, as Flying Solomon keeps urging me to. It's the way I want it to be, a faster pace. So I'm going to try and just drop that in there and then go back and explain it, rather than trying to build up to it. "56 possible states." Well, one way we could confirm it is by making a list. Like, alright, here we go. Here's my list. 4, 1, 2, 3, 4, 1, 2, boop, doop, 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 doop. Alright. So my list will look like this. We're just counting up. you know what song? While I'm not looking at the chat, I'll just throw out random shit, and you guys can comment on it while I can't see. Do you know what song I have stuck in my head? I've had this song stuck in my head for a couple of days now. Is the Mario Odyssey theme song. I don't have a Switch, and I haven't played any Mario Odyssey, but I was looking around for music to put on, and I was thinking, you know, a lot of people think Mario Odyssey is pretty good. Maybe it's got good music, and so I put it on. And I put on like a playlist of just like the whole soundtrack, and that was the first song on it, and ever since then it's stuck in my head. Alright, so then to find the next item in the list, we flip the bit at the end, and if that bit was 1, we carry the change over to the next bit. Maybe include one more to show a bigger rollover like this. Okay. Of course, to confirm that there are 256 states this way, we would have to go through the work of writing the whole list and then counting it. A faster method instead we can turn to mathematics to use a little combinatorial reasoning. The first bit has 2 possible states. The first and second bit combined have, when we combine the first, when we group the first bit with the second bit, we get 2 times 2 states. When we group in a third bit, we get 2 times 2 times 2. Okay. This continues until if we continue this way, so on. For a group of 8 bits, we would get 2 times 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 2 equals 256. Alright, now I'm going to stop and see if the chat likes or dislikes what I've done so far. Yeah, I like a lot of the music from Mario Odyssey. I also like uh, uh, I also like the new Donk. Well, basically everything in the new Donk City, I liked quite a bit. The remixes of old Mario stuff. So, Flying Solomon, you're telling me that I should not explain or make assumptions. But here's the thing: is I can't do both of those things. If I do not explain myself, then I'm making the assumption that they understand. If I make the assumption that they understand, well, that's not that kind of course. I could just take that out. It's the same sentence. Nice, nice. Well played. Uh, yeah, so I think I like this. Hopefully this is good. I know less is more. That's part of the problem is this is something I don't think people totally appreciate, which is that it's not always obvious what the simple thing to do is. Sometimes the first thing that occurs to you is more complicated than the simplest thing to do. Um, Simple doesn't mean easy. So again, I have another I have another paradox there, which is that if I take the time to keep this brief, it's going to take me a lot longer to write it. If I'm just getting the content down and doing formulation later, then that's the way it turns out. So, you know, the primary problem, of course, is that I have no natural talent at this English language. I see. All right. So, Flying Solomon, you just keep doing that then. Every time I start swinging the pendulum one way, you act as the force that brings me back towards the middle. And I'll never rest there. I'll just undulate back and forth near the middle, as a pendulum should. And then, of course, the lesson will read in this crazy way where you're like, well, this part feels really rushed, and then this part over here is, like, long and rambly, and, like, I can't, figure out what's going on because it's always, like, different tones everywhere. I'm sure all this stuff will work out as I work on it more, but let me keep doing this. So that's an hour in. I think we can do 2 hours today. Alright, so now I have established that we have 256 states in a byte, I think. Now I want to go back to no, that's I hope someone else, someone like, I don't know, Andrew Chronister, for instance, who really knows English. I mean, English is my first language, so you'd think I'd like have a good grasp on it, but I actually don't. Like, I get grammar, but I don't get spelling, and I can't really produce prose very well. It's tricky. I'm gonna write that down. I like. I've been taking suggestions for things to check out. I will check it out. Okay. So a byte has 256 states, but does but does that Okay, how can we ever get to 2? The next trick, the next step of understanding how computers... Here, the solution is the next step of this process. The next step is a bit more subtle. Is not anywhere computer, it is conceptual. Is that we can interpret each bit pattern as a different number. Are still actually just storing bit patterns, but who is to say what those bit patterns mean? We are. Okay. I have a very strong temptation these days to make a little editor for in4coder for these kinds of tables, because this is not the only time I spend manipulating them. Org mode, yes, basically. A natural pairing between bit patterns and numbers that interpretation from bit patterns to numbers that computers actually use. Well, a part of the problem here is I did have an outline, but I didn't really get any feedback on the outline. I mean, it's hard from the outline for people to really give concrete feedback. It wasn't until I wrote the sentenced version that I got the feedback that the organization of the whole thing was wrong. And that wasn't directly the feedback. That was kind of what I realized after reading through the feedback myself. So this is kind of after having done a sort of loose outline. Now I could probably outline in more detail than I do. It's true. But yeah, I don't think I could have avoided having to do the rewrite. All right. There we go. So now we've established that the way we have numbers in computers is sort of imaginarily by changing what we mean when we look at a particular pattern of bits. It might seem like this idea of just reinterpreting the bit patterns This idea of reinterpreting the meaning of the data, I'm editing again, is very powerful in computing. It's how we store numbers, anything we want to store on a computer is actually just a reinterpretation of. If you want to store a new kind of data on a computer, you build a programmer wants to store any kind of data, you build it out of existing kinds of data and it ultimately all goes back to bit patterns. Okay. For instance, now that we have a way for a computer to reason about numbers, we can start talking about reasoning with colors too. Again, we will associate, in this case, we will associate each number with a brightness. 0 will be the darkest a pixel can be associated with a pixel being as dark as possible. 255 will be associated with a pixel being as bright as possible. Everything else in between will be formed by gradually getting brighter as the numbers get bigger. Here are a few shades, and the number paired with the numbers they Yeah, I get that, Anton. I'm not really upset that no one gave feedback. I'm more saying I don't think there is any way that you could give feedback. There's no way without writing the full lesson to fully communicate my idea. Like, if I have an idea in my head and I write you an outline for it, that outline might reveal a problem, but the outline might look good even though I've got a flaw with the actual idea. And this is kind of a devil is in the details thing. It wasn't clear to me until after I looked at it again that the order was probably wrong, that there was no good way to explain things in the order I thought I was going to explain them. Because really, I thought that it was more fundamental to talk about the operations first and the rules behind them, and then look at the lower level details of how that gets stored in binary and then the assembly. But it turns out that what looked like a natural ordering there was just wrong. It's much harder to talk about investigating the effects of the arithmetic without having that idea of binary in place already, because there's all kinds of stuff that happens, like the effect of rolling over at 256, the limit of the number of shades that are available, the division by zero stuff. A lot of that makes a lot more sense when you have already thought about what bits and numbers do with each other, like how one goes to the other. And so yeah, I think that there's some kind of an unavoidability problem with the outlines, and I'm going to take Flying Solomon's Like, there's no way for you to pick up on problems any more than there is a way for me to pick up on those problems until after I've written it and seen the issue. But I'm going to take Flying Solomon's advice and shut off the screen while I make this work. Alright, what do I want to say here? Here are a few pixel shades and the number that goes with them, and this table shows how a few numbers get interpreted as particular pixel shades. And then this table here would look like this. I need to look at what pictures I have here. I've got 0, 1, 2, 3, 8, 0, 8, yeah, okay. These are wrong. 0, 1, 0, 3. Whoops, no, I didn't want Windows help, thank you. 0, 2. Alright, 1, 2, 3, 4, 5, da, 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 da. Alright, we're going to need my calculator, programmer, hex 808. Wait, no, don't do that. That's just 128. Okay. I would have known that if I wasn't thinking 808080. Okay. So we want 0, 1, 2, 3. And then 128. And then those ones. And then what I want to do is take out all these. Let's leave the bits in, actually. That can't possibly hurt. Oh, I did the tables wrong. Ah, I have to fix this. I know, Flying Solomon, I know. I don't care, I'm gonna fix it. There we go. Okay, I need a lot of space there. 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 And then I need to, like, link in some images. So this will go, link image. Why don't I do it this way? Link image. That was definitely the faster way. There we go. So then I'll link in little swaths of shades of gray there. And right here I want to add hidden layer word size. It's not just groups of 8 bits in the hardware. Okay. Hello there, Aaliyah Christian. Welcome to the stream. Christian? I don't know. I think I said that right. Okay, so we're doing alright. There's a hidden layer here about the fact that 8 bits form a byte, but a byte's not really the actual thing the hardware does. Exactly. So, there's only one thing left to do. Actually, putting the table in like that is a good idea, because now we can go how to notice that now we have two different ways to interpret a bit pattern. How does the computer know which interpretation to use? Does it spend an extra bit somewhere on that? Are there some kind of modes? The answer is that the computer doesn't exactly know what answer that the computer doesn't do anything special at all to keep track of what interpretation instead, when the computer goes to look for the pixel color data, it just takes whatever could accidentally store something that was meant to be a number. The byte is simultaneously a 0, the color black, and many other things, and possibly many other things. All that matters is that if that byte gets used as a color, it will be black. A moment later, that same byte could be used as a number, then it is a 0. The meaning of of the byte is... This is going to sound weirdly philosophical, but it's true. The meaning of the byte is determined when you decide when the computer, by how the computer is using it. Okay. Alright, so that got weirdly philosophical. That topic always gets philosophical. You can't really avoid it. What is the meaning of data? What is the meaning of life? Who knows? It all comes down to how the computer is using it. Alright, how are we doing on time? We got 30 more minutes. In an hour and a half, I got this section knocked out. Bit numbers and colors. That's a pretty important one. Paintings of arithmetic. I think I'm going to stop here for today. There's obviously more to write, but I need to give my head a moment to cool down on that one. And maybe I'll stream again next time I start working on this or something, and we'll do paintings of arithmetic then. But I think that's as much work I can do on this right now. I don't have a lot of stamina for it. I'm wondering, I'm going to take a quick moment to not going to shut the stream down just yet. Take a quick moment to look around, see if there are any questions, comments, thoughts. Flying Solomon, do you have access to the Handmade Network repo? I forget if you have a different username somewhere. I know, like Anton Swifton, for instance, if he's still here, will probably edit this when I post it. Then yeah. By the way, I did say before I do finish this up, I said I wanted to make sure I updated README. This is all wrong. Lesson 2 is ready for draft 1. Alright, anything else? Alright. Roadmap. Yeah. So this is where I want to expand this out. So this is lesson 1 still. We're going to do arithmetic on unsigned char is this lesson. this lesson, I'm adding more lessons now, because a lot of the stuff that I did in the original version of lesson 2 got moved to lesson 6, the preprocessor, but there's more stuff in between. Arithmetic on unsigned char, arithmetic again, this time on lots of types. So here we learn the arithmetic operators and variables and things. Here we learn about types, and we again see how changing type can change the instructions that get used and stuff. Alright, so there's that. Now control flow, if else while, the program counter go to, that's too much in one batch. We're going to do if else, while, do for, program counter go to, and the program counter. This might be able to go all in one like that. I'm still not convinced that I know the best order to do control flow, because the program counter is super important, and you don't really think about the program counter until you can do control flow. It's just not an obvious thing that matters. But once you're doing ifs, you're going to look at the assembly and go like, here's the if in the assembly and the control flow. Like, go-to is actually easier in assembly than these other things. These other things boil down to more complicated assembly, but they're simpler C. Or at least they're the C that everyone prefers, but I wonder if go-to should come first. I have this, I'm just going to play with that. I feel like go-to should come first. Then we're going to get pointers, arrays, memory and allocation, procedures, the stack, function pointers, maybe something that's good. 12, the preprocessor. I feel like I'm going to reorder this. Let's see. I feel like that I could. You know, I'm going to make this a special lesson right here. Like an offshoot lesson, because it's not quite in the same spirit as everything else, because it's more tools that you don't necessarily have. Yeah, this is all stuff that I may or may not do experimental ideas for after that, but let's see. At this point, have I missed anything at all? This is what's great about the language C, which is that, like, that's a full description of it. That I think that talks about every single feature that exists. Could do the standard library, but I don't really want to. Not quite sure about that, but we'll work on it. I said I don't go over all the possible operators, but if we'll cover Boolean operators, yeah, so I skip out a couple of little operators here and there, like ternary and the bit operators don't come up, but everything else will. There you go. That's it. That's what I need. Pointers, arrays. We're going to do this one here. Structs, unions. Yeah. Yeah, so structs, unions, enums, type def. I feel like would make one lesson. Although you could easily expand on some of the details in structs and unions for a while. I feel like an advanced structs and unions lesson would be good. Like some of these I feel like they deserve an advanced version. Function pointers are down here. Yeah, it's 213s because this is a like continuation. Maybe I should do this one this way. This is like an advanced continuation on that. This is all a little bit guessworky, but I am trying to make a slightly good approximation of how many lessons I want to make. And this is at 13 right now, with 3 other ideas of things I might do later. Ah, switch. I'm missing switch. So one thing I'm thinking about is, if you introduce goTo first, you have the problem that you can't actually use it in a useful way. You either will create an infinite loop, or you'll just be skipping over code. Really, you need if-else first. I think we can swing that. I think that's okay. I'm not sure you're talking about become a reviewer of the wiki. I don't actually know about that. I mean, I probably should. I'm sure I've heard Abner explain it before, but I don't actually know. Do they just have to make him a person on the account on the network, get in touch with Abner or something like that? Markio with VMF asks, will you cover compilation-related topics like translation units, linking, symbol tables, Unity builds? So lesson 1 kind of covers the very basics of that. Maybe I ought to put in an advanced version of lesson 1 someday that covers things like what you're mentioning, because I don't actually have that in the plan right now. So, I'm a little not sure what to do with these 2 lessons here. So, I could break up switch and the loops. What I'm thinking right now is lesson 4 gives you the basics. You don't actually even need else in here technically, but if is the only thing else ever goes with. There's no other way to introduce else. It really should be introduced with the introduction of if. But if and goTo are the 2 fundamental building blocks from which you can build the others, is basically the idea I've got. So that might be the wrong way to think about it. Maybe I should do the high-level ones first and then break that down. But introducing switch before if seems odd too. But the point is, maybe not. That could be good. But maybe not. The idea I'm kind of going with here is start by like just manipulating the program counter and look at that idea that there's a program counter, and the simplest thing you could do there is show a goto that moves it and an if that lets it branch, right? There's like a jump and a conditional branch are the two things you need to understand there. And you can't do conditions without if. You can't do loops with just if. You can't. If I could, I would just pick one thing and be like, here's the thing that does the program counter. But you know, like that would be like while, right? It does a branch and a loop. But I feel like that starts to get higher level. You can't do a thing that's just like, I just want to see the program counter jump to some other place and do nothing else. Like the simplest way to see the program counter jump is with goto. The simplest way to see a conditional operation is with if. So put those together, and then the rest of the control flow stuff, we just fill that out in the next lesson. But maybe that's too many things in one lesson. I'm not sure. So they're already going to see ASM instructions, but they're not going to see any ASM instructions that do control flow. So they would have as much of a reason to understand control flow given the C that they had already, like the C that they've already seen will have more control flow in it than the assembly they're going to have seen. And yeah, Flying Solomon, that's kind of true. I mean, if you look at assembly, what you basically have are a goto and an if. The if isn't really an if the way we think about it now. Like ifs are kind of backwards. Or what I should say is assembly instructions are backwards, because usually your assembly instruction looks something like branch to this location on this condition, which means it's the opposite of an if, which says do the next line of code on this condition. Otherwise branch, right? But yeah, basically you have something that works basically like an if, and another thing that works basically like a goto. And then out of that you can build else, switch, while, do, for. I'm not really concerned about the order in which it happens historically for the purpose of the lesson. I don't care too much. What I care about more is that I introduce them in the way that makes them easiest to learn. And I'm not sure if this is the way or not. I'm not really convinced that starting with a full-blown loop is actually the easiest way to learn it, though. I feel like a loop is more complicated. I feel like the goto is the more intuitive thing. I feel like if you know if, else, goto, and then in the next lesson we can be like, now what would be really useful is if we could do this thing. And then it's like, oh, well that is built in the language. That's a while loop. And then what if we could do this thing? Ah, that's a do loop and for loop and switch. Like, show how they're built out of the previous things, and then say, now use these constructs when you can, because they make your code less messy. And in fact, especially in the case of for loop, because for loops are sort of super mystical at first, because there's this weird, like in C, the goddamn syntax is like you have like 3 expressions, so it's like for and then like expression 1, 2, 3, and then a block, and so you're like, do you do wait what? And it's like the expression order is like you do, if your expressions are A, B, C, and then block, you do A, B, block, C, B, block, C, B, block, C, B, block. It's an odd order. It's pretty useful once you use it. I like for loops quite a bit, but I like C-style for loops quite a bit. Because I like the idea that you can use the continue statement and not skip your iteration. And control what that thing you don't skip is. Like, you get control over what the thing is you don't skip with continue. It's actually it's part of the reason why I always use for loops, I guess, is what I'm saying, and never while loops. But yeah, I think building those out of if goto lets you literally see how it works, so that you just aren't there's not like a question in your mind like, is this right or not? It's like, no, yeah, according to the lesson at least, this is literally the order of operations that happens. All right. I think that is the new roadmap. So I'm going to set all of this to question marks for now. I don't know when any of this is getting done. Okay, new roadmap. All right, thanks everyone for coming and hanging out and chatting and whatnot. I will probably keep doing this because I had a good fun and I think it will make me more productive on this project. So thanks again for coming to check it out, and I'll see you guys later. Bye.